Okay, so you ever wonder how your phone pulls off all those crazy AI tricks without, just bursting into flames? Well, today we're going to pull back the curtain on one of AI's smartest tricks, the teacher-student model. This is the secret sauce for how we get these massive, brainy AIs onto the tiny devices we use every single day. Seriously, let's just start there. How do you fit a giant AI on your phone? I mean, think about it. You've got these incredible features like real-time translation or super advanced photo editing, and somehow your phone isn't melting or dying in 5 minutes. The AIs that power this stuff are huge, so what's the trick? All right, so here's the fundamental problem. The biggest, baddest AI models out there, they're kind of like digital elephants. They're incredibly powerful, super smart, but they are just massive. They need a ton of power, a ton of resources to even move. Resources that your phone or your car or most everyday gadgets just don't have. And this really shows you the disconnect, right? On one hand, you've got the giant AI chilling in a data center. It's high power, super expensive to run. On the other hand, you've got your phone. It's got to be low power, low cost, and it needs to be fast. That's what we call inference. The AI has to make a decision, like right now. These two things seem like they're from different planets, totally incompatible. So yeah, that's AI's big problem in a nutshell. You've got this epic clash between huge power and tiny spaces. So, how do we fix it? Well, lucky for us, there's a really, really clever solution, and it's based on an idea that, honestly, we can all get behind: the teacher and the student. So here's the big idea. You don't actually try to shrink the giant teacher AI. Instead, you create a brand new, much smaller, more agile model, the student. And this student has one job, and one job only: learn to perfectly mimic the teacher. Think of it like a master chef teaching an apprentice. The goal isn't just to follow a recipe. It's to cook the dish so it tastes exactly the same as the master's, but maybe, in a much smaller kitchen. And let's be super clear about this. We're not trying to make a dumber version of the AI, not at all. The real goal here is to basically distill all of that teacher's wisdom and intelligence into a tiny, efficient package that can run anywhere, anytime. Okay, so this chart kind of breaks down the key difference. With normal AI training, you use what are called hard labels. You show it a picture and say, this is a cat. That is not a cat. Super black and white. But with the teacher-student method, you use soft labels. This is the cool part. The student doesn't just learn the final answer is cat. It learns why the teacher thinks it's a cat. It learns that the teacher is, say, 98% sure it's a cat, but also sees a tiny 2% chance it could be a fluffy dog. It's that nuance, that deeper reasoning, that's the magic trick. That's how the smaller student model gets so smart, so fast. So how does this all work? How does the teacher actually pass down its knowledge to the student? Let's get into the nitty-gritty. All right. The fancy term for all this is knowledge distillation. And yeah, the basic idea had been floating around for a bit, but it was a really big deal in 2015 when Geoffrey Hinton, one of the godfathers of AI, and his team published a paper that basically laid it all out. That's what really kicked this whole thing into the mainstream. It really just boils down to 3 main steps. Step 1, you take your huge teacher model and you train it on a massive data set until it's an absolute expert. Step 2, this is key, you train the smaller student model, but not on the original data. Nope, you train it on the teacher's answers. It's basically learning to copy its mentor's homework, but in a good way. And finally, step 3, you take that small, fast, efficient student model and release it into the wild on all our devices. And this is really the most important takeaway here. The student isn't just memorizing a list of correct answers. It's learning the teacher's entire thought process. It's absorbing the subtle patterns, the nuances, the gut feelings the teacher developed, and because of that, the student can make smart, accurate decisions on its own, even when it sees something totally new. Okay, that's all cool from a techie perspective, but what does it actually mean for you? Well, this is where it gets real. This is literally AI in your pocket. Seriously, this stuff is everywhere. It's in self-driving cars, helping them identify objects in the blink of an eye. It's the reason those chatbots and translation apps on your phone are so quick and responsive. Basically, if there's a cool, complex AI feature on your phone, there's a very good chance knowledge distillation is working its magic behind the scenes. And it's not just about making your apps run better. Get this. Researchers are using the exact same idea to teach robots how to walk. You have a teacher AI that already knows how, and it guides a student robot. It's a way to supercharge the learning process for something that's incredibly difficult. Now, I don't want to make it sound like this is some magic bullet that solves everything. It's not perfect. It has its own challenges, and the whole field is evolving really fast to try and solve them. So let's talk about the future. Okay, so one of the biggest problems is something you could call the knowledge gap. Imagine the teacher model is Albert Einstein, and the student model is, well, way simpler. The knowledge just doesn't transfer properly. It's like trying to explain quantum physics to a toddler. They're just not going to get it. And the student's performance really takes a hit. But, of course, researchers are coming up with some really creative fixes. For instance, they're using teacher assistants. You can think of them like a TA in a college class. They're these middleman models that help bridge that huge gap between the genius professor and the brand new student. And that's just one idea. This whole area is changing all the time. And what's really wild is that even though this technique is already being used all over the place, the deep, fundamental theory behind it is still being figured out. This quote here from the machine learning community kind of gets at that. They're asking, is there a solid mathematical reason this works? It's one of those classic situations where the engineering, the practical application, is way ahead of the pure science. We know it works, but we're still nailing down the why. So at the end of the day, we're left with this really powerful concept, right? We have a way for AI to teach AI, to pass on its knowledge and create smaller, faster, more efficient versions of itself. Which leaves us with a pretty big question to chew on. If AI can teach AI to be smarter, what happens when today's student becomes tomorrow's teacher?